Today's lesson is on systems of linear equations. First, we're going to solve the system of linear equations using a table. So our system of linear equations is y equals x minus 5 and y equals negative 3x plus 7. We're going to go ahead and fill out our table, and we're going to use the x values of 0, 1, 2, and 3. So we'll plug these x values in and solve for y for both equations. So let's start with the first one, y equals x minus 5. I'll first plug my 0 in for x, so 0 minus 5 is negative 5. So y equals negative 5, which is my ordered pair 0, negative 5. Now I'll plug in 1 for x, and 1 minus 5 is negative 4. So y equals negative 4, and the ordered pair is 1, negative 4. Now I plug in 2 for x. 2 minus 5 is negative 3, so y equals negative 3, and my ordered pair is 2, negative 3. And now I'll plug in 3 for x. 3 minus 5 is negative 2, so y equals negative 2, and my ordered pair is 3, negative 2. Now I'm going to do the same thing for my second equation, y equals negative 3x plus 7. So if x equals 0, I have negative 3 times 0, which is 0, plus 7 is 7. So y equals 7, and my ordered pair is 0, 7. Next I have that x equals 1. So negative 3 times 1 is negative 3, plus 7 is 4. So y equals 4, and my ordered pair is 1, 4. Now x equals 2. So I have negative 3 times 2, which is negative 6, plus 7 is 1. So y equals 1, and my ordered pair is 2, 1. And then I have that x equals 3. So negative 3 times 3 is negative 9, plus 7 is negative 2. So y equals negative 2, and my ordered pair is 3, negative 2. Now let's look at our table. You will notice in our table that when we plug in 3 for x on both equations, we get the same solution for y. So both times we plugged in 3, we got that y equals negative 2. So this would be the solution to our system of linear equations. The solution would be 3, negative 2. Now we're going to solve a system of linear equations using a graph. Our system of linear equations is y equals x and y equals 2x plus 1. So first we're going to graph the first equation. So we have y equals x. For this equation, the y-intercept is 0 because we do not have anything that we are adding or subtracting from x. So we could say plus 0 and it would be the same equation. So we'll go ahead and plot that the y-intercept is 0. Now we can use our slope to plot additional points. The slope is 1. We do not have any numbers in front of our x, so the slope would be 1. So from our original point at 0, we can go up 1 and to the right 1 to plot the next point. And then again, we can go up 1 and to the right 1 to plot an additional point. Now we can draw the line. This is the line or the graph of y equals x. Next, we need to graph the second equation. So we have y equals 2x plus 1. The y-intercept is 1. So we can go ahead and plot that point at y equals 1. Then we can use our slope, which is 2, to plot additional points. So from the point we have, we would go up 2, 1, 2, and then to the right 1, and plot our point. And then again up 2, 1, 2, and then over 1 to plot the point. Now we can graph the line. To find the solution using a graph, we want to see where the two lines intersect, or where they meet. And you can see that they intersect right here. So now we need to identify this point where they intersect. And this point, if we are here at 0, 0, would be negative 1, negative 1. So the solution to this system of linear equations is negative 1, negative 1, because this is where they intersect on the graph. Now we're going to solve the system of linear equations algebraically. So for number 3, we have x plus y equals 20, and we have y equals 2x minus 1. So the first thing we need to do is we need to solve each of these equations for the same variable. So we could have both of them say x equals, or they could both say y equals. Since our second equation already has y equals 2x minus 1, the easiest thing to do would then be to solve the first equation for y. So we have that x plus y equals 20. We can solve this for y by subtracting x from both sides. Then we'll have that y equals negative x plus 20. So now we have that y equals negative x plus 20, and our second equation was y equals 2x minus 1. If we know that y equals negative x plus 20 and y equals 2x minus 1, we could also say that negative x plus 20 is equal to 2x minus 1. We basically just replaced this y with the 2x minus 1. We know that both the right side of each of our equations is equal to y, so they must be equal to each other. Now we can solve the equation we made here. So negative x plus 20 equals 2x minus 1. So we could go ahead and we could add x to each side. Then we would get that 20 equals 3x minus 1. Now we could add 1 to each side. Then we would have that 21 equals 3x. Last, we can divide by 3, and that tells us that x equals 7. Now we know that x equals 7, and what we can do next then is plug this 7 in to one of our original equations, it doesn't matter which one, and we can then solve for y. So I'll go ahead and choose the second one. I have y equals 2x minus 1, and I'm going to go ahead and plug in 7 for x. So I have y equals 2 times 7 minus 1. So we have y equals 2 times 7, which is 14, and then minus 1. So we get that y equals 13, because 14 minus 1 is 13. So we know that the solution to this system of linear equations would be 7, 13, because my x value is 7, and my y value is 13. This means that if I plug in 7 to each of my equations, I'm going to get that y equals 13. So we can see here that if x is 7 and y is 13, 7 plus 13 equals 20. For the second one, if we plug in 7 for x, 2 times 7 is 14, minus 1 is 13, which is our y value. So 7, 13 is the solution to this system of linear equations.